Hello, welcome to the galaxy classification video. This will hopefully help you along the next module. So the Hubble tuning fork is a diagram created by astronomer Edwin Hubble in the 1920s to classify galaxies based on their observed shapes and structures. The diagram represents a way of organizing galaxies into different types, primarily focusing on their morphology, which is the shape, and their evolution. Now, there are some extremely detailed versions of this, but for our intended purposes, we will just stick to this classic version. So on the far left, you will see a series of elliptical galaxies labeled E0, E3, and E6. The E stands for elliptical, and the numbers 1 through 6 indicate their degree of elongation, E0 being nearly spherical and E6 being more elongated. So elliptical galaxies usually contain very little dust and gas and show very little organization of structure. The stars orbit around a core in random directions and are generally older than those in spiral galaxies, since there's little gas to form these new stars. And this is another beautiful example of an elliptical. So next we have the SO galaxies, or the lenticular galaxies. They're a cross between spirals and ellipticals. They have a central bulge and a disk common to spiral galaxies, but no arms. But unlike ellipticals, lenticular galaxies have older stellar populations and very little ongoing star formation. Scientists have a few theories about how lenticular galaxies evolved. One idea suggests these galaxies are older spirals whose arms have faded. Another proposed that lenticulars formed from mergers of spiral galaxies. Now we get to the spiral galaxies with the presence of arms, classified as SA through SC. The S stands for spiral, and the letters A, B, C indicate the tightness of the spiral arms and the size of the central bulge. In the bottom row, the SB prefix indicates the presence of a bar. These galaxies have a central bar shape structure made of stars with spiral arms originating from the ends of the bar. Spiral galaxies are beautiful galaxies that resemble giant rotating pinwheels like a pancake, with a pancake-like disk of stars and a central bulge, or a tight concentration of stars. This is what we consider the bulge. The youngest stars form in gas-rich arms, while older stars can be found throughout the disk and within the bulge and halo. Spiral galaxies are also surrounded by halos, mixtures of old stars, star clusters, and dark matter, invisible material that does not emit or reflect light, but still has a gravitational pull on the other matter. Both the Milky Way, which is our home galaxy, and the Andromeda galaxy belong to a subtype known as barred spirals, which make up 2/3 of the group. Barred spirals sport ribbons of stars, gas, and dust that cut across their centers. Scientists think the presence of a bar indicates that a galaxy has reached full maturity. Lastly, but surely not least, over to the far right we see the IRR, which represents irregular galaxies. There are 3 categories of irregulars: irregular 1, irregular 2, and dwarf irregular, but we won't get into all that today. Irregular galaxies have unusual shapes like toothpicks, rings, or even little groupings of stars. They range from dwarf irregular galaxies with 100 million times the Sun's mass to large ones weighing 10 billion solar masses. They often appear chaotic and asymmetric, and are typically smaller than spirals or elliptical galaxies. This is the Large Magellanic Cloud, one of our closest neighbors in the local universe, and actually orbits around the Milky Way. The LMC is classified as a dwarf irregular galaxy. These galaxies can contain a lot of gas and dust, leading to active star formation. And you can see where all of these very bright, young blue and white stars are. Irregular galaxies may result from interactions or mergers between galaxies. I find this particularly interesting since my research often involves looking in these type of environments for globular clusters. Well, that's it for galaxy classifications. I hope you found this video helped. You learned something new, and now you can impress your friends and family with cool facts about the different galaxy types. Thanks for watching.